1.6a. Okay, what we talked about last time, recall if f of x equals x squared, f prime of x equals, we bring the 2 over, and then we minus 1 from the exponent, which is just 2x. Okay, and then we went on to say we can evaluate f prime of 1, which would be 2 times 1, which equals 2. And this represented the slope of the tangent line. At f of 1. Okay, so let's do some warm-up problems. If y equals 4x to the 7th, y prime equals 7 times 4, which is 28, and then we take away 1 from the 7 to the 6th. Okay, if y equals 3x, then y prime equals, we just take away the x and we get 3. Now why and how would that work? Well, if this is x to the 1, so I'm going to go back. I'm going to do the long way. Since this would be x to the 1, we'd go 1 times 3, which is 3, and then we would take away 1, which is 3 times x to the 0, which is 3 times 1, which equals 3. So in short, whenever we have just a constant, I'm going to give you another example. If we just have a constant next to x, in short, there you go. Just take away the x, and this is y. Okay, so if we had another problem, let's say we had y equals 5, and we want to take the derivative. Well, the answer is 0. The derivative of any constant is 0. And this is why. We could rewrite this right here as y equals 5x to the 0, because x to the 0 is 1. And if we were to take the derivative of that, we'd bring the 0 times 5, and 0 times 5 is 0. And then we'd minus 1, and that just gives us 0. So, in review, the derivative of any constant is just 0. Okay, so let's do a little bit more review on a longer problem. Let's do dy dx. This is just another way of saying the derivative of 3x squared minus 4x plus 2. What we do here is we take every term and take the derivative. So the derivative of 3x squared is 2 times 3 is 6, minus 1 just gives us 6x. The derivative of negative 4x is just minus 4. And the derivative of 2 is just 0. You don't have to write plus 0, but while we're learning, we'll just go ahead and do that. So our answer is 6x minus 4. Okay, so what we're going to learn today are 2 different rules for taking derivatives. The first one's called the product rule, and we will use this a lot. The product rule. Okay, so here's an example. Well, we'll get to an example. Here's pretty much what it is. If f of x, capital F of x, equals f of x times g of x. If f of x equals f of x times g of x, then f prime of x equals f of x times g prime of x plus f prime of x times g of x. Now I know that looks like a whole lot of, what is that? Well, it's not as hard as it looks. Okay, we'll do an example. But before we do, let's look at it again. If we have 2 functions that multiply each other, that's all the product rule says. Product means multiply. Then the derivative is, we have a pattern. We take the first one and leave it as is, and we multiply it by the derivative of the second one. And then we add that to the derivative of the first one times the regular g of x, the second one. Okay, so let's do an example now. Here's an example. We're going to say let y equal 3x to the fourth times 2x cubed minus 4x. So there we go, we have a function. Now notice we could label this one right here f of x, and we could label this one g of x. We notice they're multiplied. Okay, so let's apply the product rule to find the derivative. The product rule says we just leave f of x as it is, so we're going to do that, 3x to the 4. And then we multiply that by the derivative. Since we're taking the derivative, I'm going to go ahead and put parentheses here. So we're calling this g of x. So let's take the derivative. The derivative of this term, 3 times 2 is 6, minus 1 from 3 is 2. The derivative of negative 4x is just minus 4. So far what we've done here is right here. That's all we've done. Now we're going to put a plus sign. We're going to take a derivative of f of x. Since we're calling this one f of x, we'll take the derivative of this. 4 times 3 is 12. And then we take away 1. So 12x cubed. We took the derivative and now we times it just by g of x, using parentheses so we can remember to distribute properly. Okay, so let's continue now. The rest is just algebra. We're going to distribute. So 3 times 6 is 18. X to the 4, x to the 2, we add the exponent, which is x to the 6. 3 times negative 4 is minus 12. And we leave the x to the 4. Okay, let's go on to this one now. We have a positive. 12 times 2 is 24. And x3 times x3, we add the exponents, gives us x to the 6. And then we go ahead and distribute 12x to the 3 times negative 4x. Negative 4 times 12 is minus 48. And then we have an x to the 3 and an x to the 1. We add them, gives us x to the 4. All right, now we combine the same exponents. Here we have x to the 6, x to the 6, which equals 42x to the 6. And then we have a negative 12x4 and a negative 48x4. We combine our negatives and it gives us minus 60x to the 4th.